Good afternoon, fifth graders. Actually, my room 10 peeps. How you guys doing? Hope you're doing well. Hope you're staying healthy. Wash those hands. 20 seconds, remember? Use soap. Use soap. All right, cool. Man, once again, miss you guys. Wish you were sitting in my classroom and I was not talking to an iPad right now. Sweet. We are on page 74 in your science book, so go ahead and grab that out. Get that science book open and ready. If you're not ready, go ahead and hit pause. If you are ready, sweet. Just let it play. All right. So we're picking up page 74 talking about solutions. So today we're going to be talking about solutions. I'm drinking a solution right now. We're going to talk about the two things that go into the solution to make it a solution. So we're going to be putting in, we got our solvent, which is going to break down the liquid or whatever it is that we put inside of it. And then we have our solute. The solute is what goes in and gets mixed up or goes in and gets dissolved inside of there. So let's rock and roll. The top of page 74, let's go. It says salt and sand do not mix evenly, but water added to the mixture does mix evenly with the salt. Salt and water form a solution, kind of like this picture behind me here. I'll explain in a little bit. A solution is a mixture in which all the substances are spread evenly throughout. The salt dissolves in the water and seems to disappear. But dissolving is the process in which the particles separate and spread evenly throughout the mixture. Other substances can dissolve and form solutions as well. Suppose you mix sugar into iced tea. You cannot observe the grains of sugar in the tea because some physical properties have changed. However, if you taste the tea, you know that sugar is there. The sugar has undergone a physical change to form a solution, but it has not become another substance. Remember, the chemical change is when something has changed to something completely new, right? Now, a physical change is you physically changed whatever that item is, but it is still holding its properties. So that sugar is still holding the properties of being sweet within that iced tea. And man, if I have iced tea, I've got so much sugar swirling around the bottom that it doesn't even dissolve anymore. And we'll talk about that either tomorrow or the next day or next week, where we talk about solubility, which is basically like how much you can get something to dissolve inside of something else. I put so much sugar in my iced tea that when I'm stirring that bad boy around, that basically like it all dissolves to the point where it can no longer dissolve and hold any more sugar. So it's like spinning around in like little granules at the bottom. That's the only way I like iced tea. Or if it's like some Lipton Brisk or something that's already kind of sweet, then I'm in. But, regular iced tea, but I mean, I'm drinking a solution right now. So right now, I put my coffee in there. My coffee is the solvent, right? You guys with me on that? Or wait. I'll talk about it after this next paragraph. Okay, next paragraph. We are on the kind of the first full paragraph in the second column on page 74. Starts with scientist. Scientists have special terms they use to describe the parts of a solution. A solute is a substance that is dissolved. That's what you put into the solvent, and it dissolves or it separates in there. A solvent is a substance that dissolves the other solute or whatever it is you're putting in. So my coffee right here, my coffee that I put in this cup, the nice black, beautiful coffee I put in here, that coffee was my solvent, right? So it's going to break down the sugar, or it's going to break down the sweetener, or it's going to break down the French vanilla cream I poured in here this morning, and I stirred it all up. So the French vanilla that I put in, that's my solute. So solvent, I pour in the solute, I stir it up, I get this tasty, delicious coffee. All right, sweet, let's keep going. Water is the most common solvent on the earth because water breaks down lots of things. Whenever you take pills at home, it says take with water. so that it helps it slide down your esophagus down to your stomach. But then also the water helps that pill dissolve along with your stomach acid. Um, it is often called the universal solvent, which is pretty cool. Water's ability to dissolve many substances is very important to life on this earth. Sweet, now we're at the top of page 75. You see a solution right here that every one of you has probably drank in your life. Unless, I don't know, sometimes people haven't had soda. I don't know how, but some people haven't had it. So, let's rock and roll. You might think that all solutions are formed from a solid item being dissolved in a liquid. That is not the case, however. Actually, the solute in the solvent of a solution can be a solid, a liquid, or a gas. Because, I mean, the liquid that I poured in here, the French creamer, French vanilla I put in here, that was a liquid. It wasn't a solid. Now, if I put sugar in there, that would have been a solid, right? I put a solid in there, I'm mixing it up. Now, even with a gas, check it out, we're gonna read about a gas here. Let's see, air is a solution of gases. So air is different gases put together. The oxygen you breathe and the carbon dioxide plants need are two of the most common gases in the air solution. A soft drink, that soda pop right there, that Mountain Dew, that Dr. Pepper, that Diet Pepsi, or that Pepsi or Coke or whatever it is. A soft drink is a solution of a gas in a liquid. So they put the gas into the soda pop, and that's what gives it the bubbles, you guys. That's what gives it the carbonation. So when you drop it and you open it, and then it sprays out everywhere. So there's carbon dioxide gas that they put inside of the liquid. It gets dissolved in there, and then that's where the bubbles come from. So the drink, the liquid, is the solvent. The carbon dioxide that goes in is the solute. That solute, remember, is what is being dissolved in the solution. And then the last but not least, the last paragraph here says, you may use metal products that are formed from a mixture of two solids. These mixtures of two or more metals are called alloys. A nickel coin is actually an alloy of the solid metals nickel and copper. Even 14 karat gold jewelry is gold that has had some silver added to it. That's why it's 14 carats instead of 24. Awesome. Now, if you've ever ridden a bike or a scooter or anything like that, a lot of the times, like if it's a nicer bike and maybe it's like really light, feels really light when you try to pick it up, it might be made of aluminum alloy. If you check on the seat post tube, like where the seat slides into your bike frame, right underneath there, usually like there's the tube that comes across and then the seat post that goes down. If you check on that, it will usually say some type of alloy, like 5051 steel or, whatever aluminum alloy might be on there. Cool. Here's an awesome picture that really breaks down how the solution goes together. So check it out. We got our solute. Remember, this is what is going to be dissolved in the solvent. So solute plus solvent, when you add those together, equals your solution. So we had water. We put this powder in the water. We stirred it up. And then, boom, that gave us our solution of this mixed blue water. So remember, solute being dissolved, solvent doing the dissolving. And then here we go with the solution. All right. Cool. Hope you guys enjoyed today's science lesson. And I think we will have some news coming down the pipe here in the next day or two about science projects and what we are going to expect for those. All right. Hope you guys are doing well, and I will talk to you guys soon.